Hello friends, welcome back to my channel. So in this video we will see another example whether the given random process is wide sense stationary or not. So we have seen two problems already. So this is the third problem. So how to check whether the given random process is wide sense stationary or not. So we have to check two conditions. One is expectation of x of t. Expectation of x of t should be constant. The second thing is the autocorrelation function, that is rxx of t comma t plus tau, which is nothing but expectation of x of t into x of t plus tau, which should be a function of only tau, that is time lag. So these two are satisfied. If these two conditions are satisfied, then we will call such a process as wide sense stationary process. So here in the problem statement it was given x of t is equal to kt. Here k is the random variable which is uniformly distributed in the range -1 to 1. So we know the density function of a random variable which is uniformly distributed is 1 by b minus a for a less than or equal to x less than or equal to b, 0 otherwise. So here k is a random variable. So we will write as fk of k. Fk of k will be, so here this is a and this is b. So 1 by 1 minus of -1, which is nothing but 1 by 2 between -1 less than or equal to k less than or equal to 1, otherwise it is simply 0. So this is the density function of the given random variable k, which is uniformly distributed in the range -1 to 1. So what is our first condition that we have to check? First condition that we have to check is expectation of x of t. Expectation of x of t is nothing but minus infinity to infinity x of t into what is the random variable here? It is k. So we have to multiply with the density function and dk. So here the density function of the random variable is exists only from -1 to 1. So it is simply -1 to 1. X of t is kt into fk of k is simply 1 by 2 dk. So here t is a constant because integration is with respect to k, and 1 by 2 is also a constant. We can write t by 2 outside integral -1 to 1 k into dk. So integration of k is k square by 2. So t by 2 into k square by 2. And the limits are -1 to 1. So if we substitute the limits t by 2, upper limit is 1 square minus of -1 whole square by 2. So which is equal to t by 2, 1 square minus -1 square is also 1 by 2. So 1 minus 1 is 0. So first condition, expectation of x of t is equal to 0, which is a constant. So first condition is satisfied. Now what is our second condition that we have to check? Expectation of x of t into x of t plus tau. Expectation of x of t into x of t plus tau, which is nothing but integral minus infinity to infinity x of t into x of t plus tau into the random variable is fk of k tk. What is x of t? Kt, and here the density function is existing between only from -1 to 1. So kt into xt plus tau means k into t plus tau, and fk of k is simply 1 by 2 dk. So here t and t plus tau are simply constant because the integration is with respect to k. So we can take t into t plus tau by 2 outside, and integral -1 to 1 k into k is k square dk. So this is equal to t into t plus tau by 2. K square integration is k cube by 3, and limits are -1 to 1. Now if we substitute the limits, t into t plus tau by 2 into 1 cube minus of -1 cube by 3. So which if we further simplify, it is equal to t into t plus tau by 2. 1 cube is simply 1, minus 1 cube is -1, so minus will become +1 by 3. So this is equal to t into t plus tau by 2 into 2 by 3. So 2 will get cancelled. So it is t into t plus tau by 3. So what is Rxx of t comma t plus tau, which is equal to t into t plus tau by 3. Observe, this is a function of this autocorrelation function is a function of t also, So the second condition is not satisfied. Autocorrelation function should be a function of only tau, but here it is a function of t as well. The second condition is not satisfied, therefore the given random process x of t is equal to k into t is not a WSS process. Why it is not a wide sense stationary process? If for a given random process to be a wide sense stationary, expectation of x of t should be constant, and the autocorrelation function should be a function of only tau. But here it is not a function of tau, it is a function of t as well. So that is why the given random process is not wide sense stationary process. I hope everyone is able to understand the problem how we have solved. So if you have any doubts, please comment in the comment section. Thank you for watching. So if you are not subscribed to my channel, please subscribe and share with your friends and classmates. Thank you for watching.